So let's go ahead and talk about the multiplication principle and permutations and combinations. Now, given this diagram, and this is actually a classic problem. Let me go ahead and bring up the textbook so that we can, what we're doing. Okay, let's look at this diagram. What this diagram represents are three towns. We have town A, town B, and town C. And there are three routes from A to B. And there are two routes from B to C. How many possible ways are there to go from A to C? Well, the easiest way to figure that out, okay, and that's what we're looking to do, how many possible ways can you go from town A to town C? And it's actually pretty easy to figure out. Let's go ahead and list the fact that we have three different routes coming out of town A. And those are little a, little b, and little c. And once I get to town B, I have two different routes that I could possibly take to go to town C. And that's going to be either route 1 or 2. So now I can list the different ways that I can get from one town to the next. I can go route A to route, I'm sorry? It is a tree diagram. It's a basic tree diagram. And what I really would start out from is have one that comes off down here, but I don't really need that because all I'm concerned about right now are these letters and numbers. I can either start in town A and take route A into B and then take route 1 into C. I could start in town A and take route A into B and then take route 2 into C. So how many possible ways can I get there? Yeah, there's 6. Hold on. One way, the second way, this is the third way, this is the fourth way, this is the fifth way, and this is the sixth way. So there are 6 ways to go. Well, there's an easier way than just listing all of them. For example, since there are 3 ways to go from town A to town B, and there are 2 ways to go from town B to town C, if I simply take 3 times 2 and get 6, that gives me the number of ways that I can go. This is the multiplication principle. You take the number of different ways that you can combine them and multiply them together. The multiplication principle is stated here in this green box. Suppose n choices must be made. I don't know how many choices there are. There's just a bunch of them. There are going to be m sub 1 ways to make the first choice, m sub 2 ways to make the second choice, m sub 3 ways to make the third choice, and so on. Then there are the product of the different ways I can make each of those choices to give me the total number of different choices that I can make. The best way to understand this is by you doing a problem. Oops, I don't want to go too far. Checkpoint A. In how many ways can 6 business tycoons line up their golf carts at the country club? Well, let's think about that for a moment. There's 6 of these guys, right? So, golf club, or golf carts. There's one spot, the second spot, the third, the fourth, the fifth, and the sixth. Yeah, we're done with the route thing. Now we're using a multiplication principle in other problems. So, how many different ways can they line up their golf carts? This is part A. Well, all 6 of them pull into the place to line up their carts, right? That means any one of 6 carts could go into the first spot. How many different carts do I have for the second spot? 5. Why? One of them's already parked. Okay? So that means I could put one of 5 carts here. What about for the third spot? One of 4 carts. The fourth spot. The fifth spot. And the final spot. Which means if I take and multiply these together, I get my answer. There are 720 different ways to arrange those golf carts. Now, what's your question? 6 times what?
Well, there were 6 guys for 6 golf carts.
Right. I'm not parking the guys, I'm just parking the golf carts.
Well, yeah, but
Just the golf carts. Okay? And this is going to bring up the point that you've got to pay very close attention to the wording in these kind of problems. Okay? What we've just done is an example of the multiplication principle, and it also brings up another operation in the pantheon of math operations. Thank you. It is up there with addition, subtraction, multiplication, division, exponents, logarithms. And what this is this is a factorial. And it can be written like this. 6 with an exclamation mark after it. And what that means is you're going to take the number 6, and then you're going to multiply it by the next least number, 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 until you finally get to 1. Your calculators have factorial keys on them. It's a matter of finding the key somewhere. That one's got a PRB key, I believe. Or not. Yeah, PRB. So if you press PRB, there's your factorial. So what you want to do is clear everything. So type in the number 6, hit your PRB key, left arrow over to that, hit equals again, boom, you're done. This is 9.2. You should have either a math or I don't know what kind of key you're going to have. Let me see, what is that? It's an 84. Okay, you're going to go to math. Yeah, okay. All right, so what you want to do is you want to type in the number 6, go to math, come all the way over to probability, scroll down to number 4, hit enter again. Pretty cool, huh? Did you find yours, Ronnie? Okay. Did everybody find theirs?
is it the exclamation?
Exclamation mark.
Right there.
Yes. So type in the number 6 and then press that key.
And that's it?
And that's it. You're done.
Oh, wow. Awesome.
Okay. Did you figure out yours, Michelle? You got yours? Did you find yours? Nope. Right there, this key right here. So just type in the number 6 and then hit that key and it'll do it automatically. All right? Cool. The n factorial right there. So hit 6. Well, you can do it. And then press that key and it should do it automatically. You shouldn't have to press equals on that. Okay, so let's look at part B right here. How many ways can 4 pupils be seated in a row with 4 seats?
So you think you do 4 plus 4 and then you do the
Not 4 plus 4.
4 times 4?
No.
4 times 3 times 2.
Yeah.
Well, but I'm saying...
How many seats do I have? 4.
You're not adding the people.
No, because I'm taking the people and I'm planting their butts in a seat.
Okay, so...
That's it. So there's 4 seats that I want to arrange. Okay. So this is going to be, for now, 4 times 3 times 2 times 1, which is 24. And yes, we could write that as 4 factorial. So here's your definition. For any natural number n factorial is equal to the number times the number minus 1 times the number minus 2, all the way down to 3 times 2 times 1. Okay? You can just put it in your calculator. By definition, 0 factorial will always be equal to 1. Just accept that for what it is. Okay? I'm not going to beyond the scope of this class. Okay? You do, though, don't you? It's just eating at you, I can tell. All right, so checkpoint number 2. 4 factorial. We already know what that is. We calculated that previously. We know what 6 factorial is, right? We calculated that previously. I just told you that 1 factorial is 1. But now, what's 6 factorial divided by 4 factorial? Well, before you start punching it into your calculator, Jesse, let's examine that for a moment. Yeah. What does this really mean? Well, 6 factorial is this, right? And 4 factorial is this. And if you look very carefully, that will just divide out, and what am I left with? As Jesse pointed out, it's 30. What's really going on here is the fact that I can rewrite 6 factorial as 6 times 5 times 4 factorial divided by 4 factorial. And then I just simply divide out the factorials. But yes, your calculator will do it quicker and more efficiently. But I want you to understand the concept behind it. Okay? Anytime. That's what I'm here for. Let's look at example number 6. And I'll tell you what we're going to do. Let's move this up here. Okay, Morse code. Uses a sequence of dots and dashes to represent letters and words. How many sequences are possible with at most 3 symbols?
It doesn't matter which one it's used.
Right.
The dots and
Right.
so you just do 8 factorial. Just 2 to the front is... Right.
I'm asking you.
Well, I'm asking you.
And you're doing a very good job of trying to puzzle it out. And I think that's awesome. Let's examine this. All right, Morse code uses a sequence of dots and dashes. Okay. So I'm either going to have a dot or I'm going to have a dash. Okay. In other words, I really only have 2 choices when I'm actually starting to use Morse code. But I can string together, and let's say 2 choices for symbols, but I can string together as many as I want. The question says, how many sequences are possible with at most 3 symbols? Well, let's think about this for a moment. That means I want to use 3 symbols. But I have 2 choices for each symbol. Say what?
So you do
Exactly. And what that is I'm going to have 3 symbols. Okay, that's my 3 symbols. And it's either going to be a dot or a dash right here, a dot or a dash right here, and a dot or a dash right here. In other words, I've got 2 choices in each spot, which is equal to 8 or 2 to the 3rd power. Now, let's talk about this for a moment. This says, at most 3 symbols. What does that really mean to you? It means it could be 1 symbol, right? Or it could be 2 symbols. What have I done right here? Just 3 symbols. Have I taken into account that maybe I'm only going to use 2 symbols? No. Have I taken into account that I'm going to use just 1 symbol? No. That's why I gave you the table. If I use 1 symbol, how many sequences could I get? Just 2. It's either a dot or a dash. If I use 2 symbols, 2 and 2, that's going to be 4. So how many total possible sequences could exist if I use at most 3 symbols? No, why? Okay. Okay. So at most 3 symbols, and that yields 14 possible sequences. Factorial? Not in this case, no. Okay. Now, yep, it's kind of providential that you asked that question. Yes, that's exactly what you're going to do. We take the fact that we're looking at the number of symbols and the number of sequences. And it's not the fact that I'm going to add together the number of symbols, because I'm not. I'm going to add together the number of sequences. So this is, 2 to the 1st power, which is 2, 2 to the 2nd power, which is 4, 2 to the 3rd power, which is 8, and 2 to the 4th power, which is 16. And then I'm going to add these up and get 30. So I got 2 plus 4 plus 8 plus 16 is equal to 30. And that is your total number of possible sequences. Okay. All right, we're going to stop there because permutations is next, and it's going to take me a little